All right, welcome back. We're going to go a little bit deeper and start finding the actual solutions of higher order polynomials. We've done it when we could just factor it using the sum and difference of cubes, or if we had a quadratic form, like a fourth degree polynomial that was a quadratic form. We did that, but not every higher order polynomial fits in those categories. So we're going to use the techniques of synthetic division and depressing the polynomial to a quadratic so that you can either factor or use the quadratic formula to then find all of the roots and zeros. So let's get started. All right, the fundamental theorem of algebra, we've talked about this before, we've just never quite named it before. It says that the total number of zeros equals the degree. So if you have a degree 3, then you have 3 solutions or 3 roots. If you have degree 4, then you have 4 solutions or 4 roots, and so on and so on and so on. Multiplicity is a term that mathematicians use when a root repeats itself, and it goes into the count. So if during the synthetic process, the synthetic division process, you find a value that gives you a 0 remainder, that's a root. Go ahead and check it again to see if it has multiplicity. Okay? The complex conjugate theorem says that complex roots always come in pairs. That's why Descartes' rule of signs, if you have a maximum number of positive roots is 3, then it's going to go down by 2 because complex roots always come in pairs. Okay? Tonight we're going to do leading coefficients of 1. Okay, that means that all of the possible zeros, that we could have are going to be factors of the constant term, whatever that very last term is that doesn't have a variable with it. Once you find one solution, then you can use the depressed polynomial to keep looking for others. And this is where I would say check that one that just produced a 0 remainder to see if it has multiplicity. Also, if a factor that you divided by doesn't work in the original, then it won't work in the depressed polynomial either. So look for those types of things to occur. So let's use our fundamental theorem. It says that whatever my degree is, that's the number of zeros. It could be complex, it could be real, but that's the number of zeros. So here my degree is 2, so my number of zeros is 2. Here my degree is 3, so the number of zeros is 3. Here my degree is 4, so the number of zeros is 4. So go ahead, answer the video question, and come back. All right. In addition to the fundamental theorem of algebra helping us to figure out solutions, we have Descartes' rule of signs. And there's basically two rules to Descartes. Okay. It says that the maximum number of positive real zeros is the same as the number of sign changes in your polynomial. So one thing that you have to recognize is what the sign of the leading coefficient is. So this is a positive. So this is a positive, this is a positive, this is a positive. Notice that I don't have any sign changes. So the maximum positive zeros is none. It can work the same way if they're all negative. Notice that I have negative, 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 negative. I don't have any sign changes, so that means that the maximum positive zeros is none. On this third example, we have to recognize that this is a positive, so now we're going to check, okay? So that's one sign change. Then it changes again, that's another sign change, but then it doesn't change, it stays positive and it stays positive. So the max positive is 2. Now, Because we can have complex roots, that means another alternative exists that we could have 0. They're going to go down by 2s. The positive and negatives are always going to go down by 2s, but you can't have negative number of solutions, okay? So this one could have 2 positives or 0 positives, okay? Now, to check the maximum number of negative real zeros, this one takes a little bit of work because you have to plug in f of negative x. F of negative x. So notice what I did. I plugged in a negative x everywhere there was an x, okay, just like we did before when we were evaluating polynomials with other expressions, okay? Now I'm going to simplify this. So this is the same as x squared. 2 times negative x is negative 2x, and then plus 4. And now I'm going to count the number of sign changes. This is a plus, so that's 1 and 2. So this is max negative is 2. All right. Now, there could be 2 of them, or there could be 0 of them, but the maximum is 2. When I plug f of negative x into this expression, I'm going to get negative 2 times negative x cubed minus x squared plus 2x minus 4. And this just becomes positive 2x cubed minus x squared plus 2x minus 4. So I have 1 sign change, 2 sign change, 3 sign change. So this is a maximum negative zeros of 3. And again, it's going to go down by 2. So this could have 3 negative zeros or 1 negative 0. Okay, so I want you to go ahead and answer the video question and then come back and we will proceed to the next slide. All right, now we're actually going to take on the task of finding all the zeros, okay? So there is our polynomial, x cubed plus 2x squared plus 9x plus 18. The total number of zeros has to be whatever the degree is, so that's 3. Notice that I don't have any sign changes in my original polynomial, so that means I'm not going to have any positive roots at all, okay? And then my negatives, I'm going to go to this next slide here for my negatives, and I'm going to plug in f of negative x for you, just so you can see it, and you get negative x cubed plus 2 times negative x, that's squared, plus 9 times negative x plus 18. All right, if I cube negative x, I get negative x cubed. If I square negative x, I get positive x squared. So this is plus 2x squared. If I multiply 9 times negative x, I get negative 9x. And then plus 18. Now I'm going to count my sign changes. Well, that's 1. That's another one. And that's another one. So I have a max of 3. I'm either going to have 3 negative roots or 1 negative root. I'm going to go back to my previous slide. And the max is 3. Okay. Now I'm going to use synthetic division to depress the polynomial to a degree 2. I only need to find 1 root. I'm only going to need to do 1 synthetic division to get me, and it be successful with a remainder of 0, and it get me to a degree 2, and then I can use other techniques. All right, so I'm going to try negative 1. I'm not going to try any of the positives because I know that I can't have any. I have maximum positive roots is none. All right, so I'm going to bring down my 1. And then 1 times negative 1 is negative 1, and I'm going to add it to 2. That's 1. 1 times negative 1 is negative 1. I'm going to add it to 9. That's 8. 8 times negative 1 is negative 8. I'm going to add that to 18, and it gives me 10. That one doesn't work. Okay? So now I'm going to test negative 2. I'm going to bring down my 1. 2 times negative 1, I'm sorry, 1 times negative 2 is negative 2. I'm going to add it to 2. That gives me 0. 0 times negative 2 is 0. I'm going to add it to 9. That gives me 9. 9 times negative 2 is negative 18 plus 0 plus 18 gives me 0. So my remainder is 0. Okay, so this is a good one. All right, and now I've depressed my polynomial. So this is x squared plus 9. That's my other factor. And I know that that has to equal 0 in order to produce a solution. So I'm going to move to the next slide here, go above where I wrote before. Okay. All right, so I have x squared plus 9 equals 0. This is not a difference of squares, be careful of that, but I can use the square root property, and I can take the square root of both sides. So you could use the quadratic formula, it would work too. So this says x squared equals negative 9. I subtracted 9 from both sides. Now I'm going to take the square root of both sides. And then I get x is equal to, I have a negative radicand, so that means I'm going to have an I, and then the square root of 9 is 3. So my solutions from the other slide, I have a negative 2 that produced a 0, and then I have plus or minus 3i. I have one real and two complex. Okay? All right. Let's try this next one. We're going to find all the zeros. All right. The total number of roots is going to be 4. My max positive is going to be none. And then I'm going to go to the next slide to determine the maximum number of negative roots that I have. Again, I'm going to do it down here because I might need some extra space. So I'm going to plug in negative x, and so I get negative x to the 4th plus 2 times negative x cubed plus 37 times negative x squared plus 12 times negative x, and then plus 36. Okay, so whenever you take a negative base to an even exponent, these go positive. So this is x to the 4th. Whenever you take a negative base to an odd exponent, it flips the sign. So this becomes negative 2x cubed plus 37x squared minus 12x plus 36. All right, so I'm going to count my sign changes. That's 1. That's 2. That's 3. And that's 4. So I have a maximum of 4 sign changes. Whoops, I went the wrong way. So I have 4 sign changes. So that means that I have the max negative is 4 roots. And now I'm going to take factors of 36 and I'm going to list them out. Those are my p's. All right. So I have plus or minus 1 and plus or minus 36, plus or minus 2, plus or minus 18, plus or minus 3, plus and minus 12, plus or minus 4, plus or minus 9, and plus or minus 6. 6 times 6 is 36. So I'm not going to check any positive roots, and for the sake of time, I'm going to kind of hurry through this. I would start at negative 1 and start working my way through. I'm going to check negative 4. I know the first 3 didn't work, so I'm going to check negative 4. Actually, I'm going to just go and check negative 6. Okay, I'm going to bring down the 1. 1 times negative 6 is negative 6, plus 12 is positive 6. 6 times negative 6 is negative 36, plus 37 is 1. 1 times negative 6 is negative 6 plus 12 is positive 6. Negative 6 times negative 6 is negative 36 plus 36 is 0. Okay, so now I have a depressed polynomial. This is an x cubed. Okay, and I know that negative 6 works. So once I find one, I'm going to check it again. If I have to keep going with synthetic division, I'm going to check it again. So I'm going to divide through by negative 6 again. I'm going to bring down my 1. 1 times negative 6 is negative 6 plus 6 is 0. 0 times negative 6 is 0 plus 1 is 1. 1 times negative 6 is negative 6 plus 6 is 0. Okay, so it did work again. So we have negative 6, 0, and that is a multiplicity, I'm going to abbreviate it, of 2. Okay, and now we have x squared plus 1, and we know that those factors have to equal we have to set that factor equal to 0. Now I'm going to move to the next slide, just so I have more room to work. And I have x squared plus 1 equals 0. Now I could use the quadratic formula, but I'm going to use the square root property because I only have 2 terms. It works the same. All right, so I have x squared is equal to negative 1. That means I'm going to have a complex root. I'm going to take the square root of both sides. I'm taking the square root of a negative radicand, so that means I'm going to have an I plus or minus 1I. So my solution is negative 6, 0, and that has a multiplicity of 2, so that means it counts as 2, and then I have plus or minus. I just don't understand why my thing is doing this goofy stuff. This doesn't seem to want to cooperate. And then I have plus I, and then I have minus I. So these are my solutions. Remember how we used to, if we had double roots, we would list it twice. Now we don't have to, we can just say multiplicity. All right. All right, and then the last thing that we're going to do is we're going to write equations from the roots, okay? So notice that the roots are negative 4, 0, 3, 0, and 5, 0, okay? So write the roots as equations, okay? So x equals negative 4, x equals negative 3, x equals 5, okay? So now what we're going to do is we're going to add 4 to both sides, and we get x plus 4 equals 0. We're going to add 3 to both sides over here, so we get x plus 3 is equal to 0. And then we're going to subtract 5 from both sides, and we get x minus 5 is equal to 0. Okay, so the reverse of the zero product property says that these three things, when you multiply them together, has to equal 0. And so we're just going to multiply. All right, I'm going to multiply, doesn't matter which way, I'm going to multiply these two together first. So I'm going to get x squared minus 5x plus 3x minus 15. I'm going to clean that up, and I get x squared plus minus 2x minus 2x minus 15, and I have to multiply that times x plus 4. So I get x cubed minus 2x squared minus 15x plus 4x squared. Come on. I don't understand, you guys. I don't understand this machine at all. Minus 8x plus 60. And then I'm going to combine like things, and I get x cubed minus 2x plus 4, minus 2x squared and plus 4x squared gives me plus 2x squared. Negative 15 and negative 8x gives me minus 23x plus 60. And here's my equation, just like that, with all of the little computer technology erasings that I have to do that make me so frustrated and a little bit salty, I'm not going to lie. All right, let's try this next one. This next one has an I as a root. So here's what you have to remember. If you're given one negative root or one complex root, you know that there has to be a second. All right, so look what I did. This was my negative I root. And then I know that the conjugate has to be a root too. So this is a positive I root. And then this is my 0 root right here. And I made them into equations. And now I'm going to add I here and add I here so that I get x plus I. I'm going to subtract I and subtract I so that I get x minus I. And then I'm going to subtract 4 and subtract 4, so I get x minus 4. Now I'm going to multiply them together. I'm going to start here. Multiply your conjugates together, because what happens is all your middle terms drop out, and you would get x squared minus I squared. But we know that I squared is equal to negative 1, so this becomes x squared plus 1 minus a negative 1. And then I'm going to multiply that by x minus 4. So I get x cubed minus 4x squared plus x minus 4 equals 0. And there we have it. There is our equation. All right. This is the daily assignment. I'll see you tomorrow. Thanks for listening.